Hello everyone and welcome back to another video. Today we'll be taking a look at a Project Euler question, and we'll be taking a look at question number 77. So here's the question in case you haven't seen it, and I'll just give you a quick chance to read it and maybe try and implement some sort of idea which you have. And okay, and now I'll go through the solution for this. So first of all, what the problem is saying is there are a certain number of ways in which you can write any number as a sum of primes. And we're interested in the first number, which can be written in the sum of primes in more than 5,000 ways. So it makes sense to start off by saying that define some f of n, which is just some function of n, which is the number of ways in which n can be represented as a sum. Okay, as a sum. And the question has basically told us that f of 10 is equal to 5, because there are exactly 5 ways in which 10 can be represented as a sum of primes obviously, but we're not going to mention that because that's obvious in the question, right? So the numbers which are less than 10, which are prime, are these numbers. Hence our sum must include these numbers. Can't include anything outside this range, since if it's outside then it wouldn't be a prime, or it would be greater than 10, so you can't have a sum. Okay, and now if we basically think that how do they generate their list? So the first thing they started off with was considering the number of ways in which we can have a sum which has 7. So if we basically have 7, then the remaining numbers, they must add up to 3, right? And there's only one way in which we can add the remaining numbers to 3. And now if we have 5 inside here, then the remaining numbers have to add up to 5. So there are basically 2 ways. You can either have 5 directly, or you can have 2 and 3. Okay? And now we basically just repeat this procedure for all the other numbers. However, there's basically one catch. So the first time I saw this problem, what I did was I thought that, okay, so the number of ways in which you can get to 10 is you can use any prime number. So you can use 7, 5, 3, or 2. And then following that, the thing which I've written inside the curly brackets, what I thought is that it would be p plus, and the number of ways in which you can get the thing in the curly brackets, I thought that would be f of 10 minus p. So then that means that our answer of f of 10 is basically going to be f of 10 minus 2 plus f of 10 minus 3 plus f of 10 minus 5 plus f of 10 minus 7. However, if we go with this approach, we basically encounter one problem. Basically, I'll just be carrying on this wrong approach, by the way, it's not correct. And then hopefully you can see why it's not correct. So if we continue with 3, and then we explore the number of ways in which we can explore, in which we can get to sum of 10, and if we have 3. So we could have a 5 or a 2, or a 7 over here, right? Could also have a few others, like we could have 2, 2, and 3 here as well. But then what we basically found is that we're actually double counting. We're basically double counting this case, because we've accounted for 2, 3, and 5 once here, but then we're also double counting that over here. So this basically gives us an insight to the problem, that the problem is not just as simple as just adding up the number of ways in which we can get to 3 plus the number of ways in which we can get to 5 plus 2. We basically need to find a way so we don't have the green double counting. And probably the neatest way to do that is we basically say that when we generate our primes, we will have them in a strictly decreasing order. So this is exactly what they've done, right? They've had it in a very strict order, which means that you can never have 3 plus 5 plus 2, because that wouldn't be abiding by the order. And ordering it doesn't actually make a difference in the number of ways in which it can be done, right? Since that's what the question's asking for. So, and now we basically define some sort of function which tracks how many ways in which we can get to a prime, having only used numbers to a certain limit. So we basically have 2 different things here. First, we have the number of ways in which we can get to n, but then the maximum prime which we can use is going to be max prime. So just to give an example of what exactly I mean by this function, the number of ways in which we can get to 10, where the maximum prime we use is 5, is basically going to be 4. And the reason for that is because if we basically look at these 5 options, in exactly 4 of them, we've used primes which are less than or equal to 5. So over here would be 4. And then the number of ways in which we can get to 10 with the maximum prime we used is 3. That would basically be 2, I believe. Or maybe it's just 1. Oh, no, it's 2. So this would be 2. And then finally, the number of ways in which we can get to 10, where the maximum prime we use is 7, this will be 5. This is basically all the ways. So this is equivalent to f of n, basically. It's equivalent to f of 10. Because f of 10 was defined to be all the ways, and the number of ways in which we can get to 10 by using a prime which is at most 7 is basically all the choices which we have, right? So the reason why this helps so much is because we basically avoid double counting this situation over here, where we have 5, 2, 3, and we also have 3, 5, 2. So that's basically how we're going to do it. And now I'll just show you the code really quickly, and you'll definitely be able to understand where exactly I'm going with this. So the first thing which we do is we generate all the prime numbers up to n, and if we define n just to be like any number, I've defined it to be 10,000, and then the reason why I've done it to be such a large number is just so we're sure that we haven't missed out any primes, right? Because the last thing we'd want to do is have like some number which is like for example, if we tried to generate f of, if we tried to generate f of 1 million, but then we were only allowed to use primes which are less than 10,000, then that wouldn't actually give us the correct answer. So, which is why we have very large number for n, just so we're sure that it generates all the primes. And the way in which we generate the primes is we basically use an algorithm called the sieve of Eratosthenes. It's a pretty famous algorithm, and it's actually pretty much the best algorithm used to generate primes. If you don't know what that is, check a video on it. Like I'm not going to be going over it now. Maybe I'll go through it at the end of the video, but and now we'll just focus on how to solve this specific problem. So, but yeah, definitely check that out if you're not familiar with that already. It's a really interesting algorithm. Okay, and now what we do is we generate some max number. So the reason why we have this max number is we're basically trying to generate all the ways in which we can add numbers until this max number. So our guess is that our answer is in the first 100 numbers, so which is why we set max number to be 100, but we can obviously increase this if it's not within the first 100 numbers. And then we basically generate the ways array. So if we recall back to what we did on the whiteboard, what we had in the ways array is we had two different parameters. So one of them was n, where n is the number of ways in which we can get to a certain number n, so in this case 10, and the max prime is the maximum prime which we used. So we explored it with 3, 5, and 7. And one thing also worth mentioning over here is that the ways of some number which is not a prime, because it's still valid to say ways of 10, 6, for example, it's just the number of ways in which we can get to 10 using primes which are at most 6. So this will basically be equal to this quantity. These two will be the same, because we obviously cannot use 6. So every number which we use will be less than, strictly less than 6. So that would be the same as less than or equal to 5. So which is why these two would be the same. Okay, and now what we do over here is we basically just explore all the different ways in which we can get to a certain number. So the number of ways in which this can be done, the number of ways in which we can get to n, p, but p is the maximum prime which we use, is going to be the number of ways in which we get to the previous prime number plus the additional ways, okay? And the additional ways is defined to over here. It's basically the ways in which we can get to that number having used the capabilities of this new prime. So what I mean here is the number of ways in which we can get to 7, for example, in this example, is the number of ways in which we can get to 7 would be the number of ways in which we can get to 5, because every way in which we can get to 5 would be included in 7, since 7 is greater than 5, plus the additional ways in which we can get to 10 using 7. So plus ways using 7. And this very intuitive idea is just what I've written inside the code on this line. So that's what we have over here. And then that's why I have on this specific line. And what we have over here is just the number of ways in which we can get to the previous prime. So we're just generating whatever the previous prime is. So basically, since we iterate over all the primes, since it's only when we get to prime number where the number of ways changes, right? Because as we saw in the previous example, the number of ways in which we can get 10 using at most 6 is the same as using at most 5, since we cannot use 6. So that's basically what we have over here, and that's what we need to implement. We just need to make sure that the number of ways in which we can get to a non-prime number is the same as the number of ways in which we get to the previous number. And we know that it will be non-prime if the number of ways to get to there is 0, right? Okay, so that's basically just what we have over here. And what we had over here was the C of Aristophanes to generate the prime numbers. Okay, so that's basically it. So now, if the first thing which we should do is just double check that our answer is correct for 10. So if we just scroll up here, okay. So basically what I've done is I've just printed the number of ways in which we can get to each number. The reason why this is -1 is because the number of, maybe I'll just make this like n, just to make it a bit more intuitive. But it's the number of ways in which we can get to n using at most n. I'll just write that over here. So the number of ways to get to n using prime at most n. So, and this should be pretty clear that this is just the number of ways. This is equal to all the ways. So, which is why I had -1 over there. And basically, we print the number of ways in which we get to n, as well as n itself. So now let's just rerun this. Okay, so it will give us the same output as if we have -1 over here, but it's just that n is a bit more intuitive. So we can see that the number of ways in which we get to 5 is 10. So that's basically like, that's correct, so that's good to see. And if you want to double check whether these are correct, feel free to do so. They are indeed correct. And we basically just need to see at which point it starts exceeding 5,000. So one way to do it is just literally just scroll, and then we can see that at 70 it's just below 5,000, at 71 it's greater than 5,000. So our answer is 71. Or just alternatively, we could just use this code, but I mean, obviously these two are equivalent. If we just want the answer like instantly, then actually I'll just have a break statement over here. So I'll just quickly explain what this does. This basically just goes through all the numbers and checks the number of ways in which you can get to that number. And if the number of ways in which you can get to that number is more than 5,000, then we print that number. If we also just break, then that will just give us the first number. So we should just get the answer, which is 71. And that is indeed the answer to this specific question. The answer is 71. So yeah, that's pretty much it. I really hope you enjoyed watching this video. Hopefully you learned something new. And if you did, please be sure to leave a like and subscribe. It would be very much appreciated. And I hope to see you another time. Thank you very much for watching. Bye.